So in this problem, we are provided with 4 points and these 4 points are collinear. We need to find out the value of k. So let us begin. Now, there's a condition if 4 points are collinear. So let's say we have 4 points denoted by x1, y1, x2, y2, x3, y3 and x4, y4. They are said to be collinear. Then the determinant, so this is a determinant where the first row contains x1, y1. So we have a determinant containing 5 rows and 2 columns. So in the first row, we have x1, y1. Second row comprises of coordinate x2, y2. Then third row has x3, y3. Fourth row is x4, y4. And then we'll again start back with the beginning, which is x1, y1. So this is going to be equals to 0. Now there's a particular way of calculating this. We'll come back to in a moment. Now since it's given here that these 4 points are collinear, so we can rewrite the determinant in terms of the values as, so we'll start with 1, 2. So here the first row is going to contain 1 and 2. Second row is going to contain negative 5, 6. Third row is going to contain the value 7, negative 4. Fourth row is going to contain k, negative 2. And then we'll end with the first coordinate that we started with. So that's 1, 2. So the condition says this: if the 4 points are collinear, then this determinant value must be equals to 0. Now how do we compute this value? So we'll start from the first row. So here we will take the sum of products. So first we'll take the product of 1 and 6. So that's going to be equals to 6. Then we add it to the product of negative 5 and negative 4. So that's going to be positive 20. Then we have 7 multiplied to negative 2, which becomes negative 14. So we add it to this value. So this is going to be negative 14. And then we add it to k times 2. So that's simply 2k. So this is going to be the sum of product. Then from here, we're going to subtract the sum of product of. So now we will have to consider negative 5 multiplied to 2. So that's going to be negative 10. Now to it, we are going to add the product of 7 and 6. So 7 and 6, they gets multiplied to give us 42. Then we have to take the product of k and negative 4. So that's going to be negative 4k. So we add that to it to get negative 4k. And then finally, we have 1 multiplied to negative 2. So that's going to be equals to simply negative 2. And this value will take the absolute value. And this absolute value must be equals to 0. Fine. Now we have 6 plus 20, so that's 26. 26 minus 14, so that's going to be 12. So we have 12 plus 2k, negative 30, positive 4k. This will be equals to 0. Now we have 2k plus 4k, so that's 6k. Then negative 30 plus 12, so that's going to be negative 18. So this will be equals to 0. Now we can also rewrite it as 6k minus 18 equals to 0. Solving for k, we have k equals to 3. Therefore, the value of k is going to be 3 such that these 4 points are collinear.